Right. So very good day to everybody. This is computer communication networks, and in this class we'll discuss about an introduction, a short introduction towards transport layer protocols. Then we discuss about UDP, user datagram protocol. Okay. So this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again let me thank God for giving me this opportunity to deliver this useful session, to share my knowledge among my fellow national, international participants, students, and young researchers. Right. So in this class, we discuss about the responsibilities of transport layer, how the transport layer works, what is the end-to-end connection procedure between the host. Then we discuss about congestion control, about the various protocols of the transport layer. Then we discuss about UDP, user datagram protocol. Finally, we are going to end this class with the UDP header and then applications of UDP. So at regular intervals, I'll be giving you some short videos to discuss the knowledge in our topics. So if you can see like OSI layer, okay, so you have like seven layers, okay. So out of this transport layer, okay, we'll have, okay, so that's nothing but the second layer in the TCP IP model, and of course in the OSI layer it is the fourth layer, okay. So for end-to-end layer, it can be used for delivering the messages to the host, okay. So you can call it as a end-to-end layer because it is offering point-to-point connection, okay, rather than hop by hop connection, okay, between the source host and the destination host in order to deliver the reliable service, okay. So here the unit of the data encapsulation, you can call it as a segment, okay. So here if you can see across the computer, here the errors are not checked at the data link layer, but here across the servers, okay. So here the errors are checked at the DLL, data link layer. So here the transport layer will be taking the services from the network layer and it will be providing the services to the application layer. So maybe in the sender side you will be having transport layer which will be receiving the message or maybe the data from the application layer, and then it will be performing segmentation, which means that here it is going to divide the actual message into number of segments, and here you are going to add the source port number as well as destination port number into the header, and it is going to transfer the message to the network layer. In the receiver side, it is going to reassemble the segmented data and it is going to read the header, okay. It is going to identify, detect the port number, and it is going to forward the message, okay, to the appropriate port in the application layer. So here are the responsibilities of the transport layer. So here we'll have process to process delivery, okay. So it's an end-to-end layer, as I told you. So here data link layer will be requiring the MAC address, like 48-bit address will be there in the NIC of every host machine, and the network layer will be requiring a IP address for appropriate routing, okay. So here the transport layer will be requiring a port number to deliver the segments of data to the correct process among several processes, okay. So here we'll be having packets transport layer. From the data from the session layer is passed across the data to the network layer, okay. So from here to here this connection, and the data from network layer is passed to the transport layer to the session layer, okay. So here the port number is nothing but a 16-bit address that is going to identify a client server program very uniquely, okay. And as I told you, instead of hop by hop, we'll have end-to-end connection, okay, between the host. So here the transport layer will be responsible for creating end-to-end connection across the host, for which it is using transmission control protocol and user datagram protocol. So TCP, it's a secure connection oriented protocol which uses handshake protocol to establish a reliable, robust connection between two end hosts. Of course, it is going to ensure reliable data delivery, and you can use it as a stateless or maybe unreliable protocol as well with the case of UDP. Okay, so UDP, unlike TCP, it's a stateless unreliable protocol, and of course it is going to ensure best effort delivery. Okay, so maybe in the flow control or maybe error control you can use it, okay, and generally for video conferencing you can use the user datagram protocol. So user datagram protocol, you can use it in the multicast application, multicast protocols. And here we'll have multiplexing. Of course, you can know multiplexing. You can combine several networks. Okay, so that is, you can use it across different applications over the network that is running on a host. So here the transport layer will be sending the packet streams from several applications simultaneously across the network. So here it will be accepting the packets from different processes. Everything will be having different port numbers. Okay, so then it will be passing across the layer. Okay, after adding the appropriate headers. Okay, and then after multiplexing you will be having demultiplexing. You can recover the original stream. Okay, so here it will be required at the receiver side to obtain the data coming from the several processes. So here transport, it is going to receive the segment of the data from the network layer, and it is going to deliver the appropriate process running on the receiver's machine. And then there is congestion problem also. For example, several sources are attempting to send the messages at the same time, means congestion problem can occur. Okay, and the router buffer starts overflowing, due to which loss of packets can occur. Okay, so which means that retransmission of packets happen, so which leads to further more congestion. Okay, so here the transport layer will be providing congestion control in several ways. So you can use open loop congestion control in order to prevent the congestion, and maybe closed loop congestion control is also there in order to remove the congestion in the network when the congestion has actually happened. Okay, so here we'll be using AIMD, additive increase multiplicative decrease. Okay, so that you can use for the leaky bucket technique for the congestion control. So here if you can see host A, it's going to transmit packets at the same time. So here the network feedback is achieved through the receiver, and the network direct network feedback is being achieved, okay, across the packet transfer. Okay. So here we'll be having the transport layer will be checking for any errors that is occurring within the messages that is being transmitted across the application layer. So using the error detection codes, you can compute the checksums, and maybe it is checking whether the received data is not corrupted, whether it is corrupted or not. So if it is not corrupted, means it will be using the acknowledgement as well as n acknowledgement services in order to inform the sender if the data has arrived or not, and maybe if it is going to check for the integrity of data. And then you will have flow control. So transport layer will be using or maybe providing the flow control mechanisms between different adjacent layers of the transmission control protocol. And of course TCP, it is going to prevent the data loss due to fast sender as well as slow receiver. Okay, so that is how it goes. Of course it uses sliding window method. Okay, so that is being accomplished by the receiver by sending a window back to the sender and informing the size of the data it is going to receive. So these are the protocols of the transport layer. We have TCP, transmission control protocol, UDP, user datagram protocol, SCTP, stream control transmission protocol, DCCP, datagram congestion control protocol, and then ATP, Apple Talk transaction protocol, FCP, fiber channel protocol, RDP, reliable data protocol, RUDP, reliable user data protocol, SST, structure stream transport, and finally SPX, sequence packet exchange. So these are the several protocols of this transport layer. Out of this we are going to discuss about UDP, user datagram protocol. So of course it's a transport layer protocol, and of course you can use it for the UDP IP suite as well. So unlike the TCP, it's a unreliable, seamless, connectionless protocol. So no need to establish the connection prior to the transfer, and of course you can establish the low latency and loss tolerating connections as well. So here it's you can use it for the process to process communication, and though TCP is the dominant transport layer protocol with the internet services, of course you can use the UDP for assured delivery, reliability, and of course you can go with the additional overhead and latency. So that is the problem you will have with the UDP. So for real-time services like maybe for computer gaming or maybe voice communication, video communication, live conferencing, you can use UDP. And generally, if with the case of UDP, high performance is generally required. So here UDP will be permitting the packets that is to be dropped instead of the process delay packets. And here there is no error checking like the TCP. So it is also going to save the bandwidth. Okay. So user datagram protocol, you can, of course, it is more efficient with consideration of the latency and the bandwidth. Then we have UDP header. So it's 8 byte. Okay, so it's actually fixed. Okay, so you'll have UDP header and UDP data. So here the first 8 bytes, okay, will be having the header information, and remaining will be having the data that is associated. So here we'll be having source port, destination port, length, and then checksum. Source port 16 bits, destination port 16 bits, length 16 bits, and then checksum 16 bits. So here the port numbers will be varying from 0 to 65,535, and here port number 0 is actually reserved. So here the port numbers will be designating or distinguishing, differentiating between different user requests for the different processes. And then you'll have the source port, of course 16 bits or maybe 2 bytes. So that is going to identify the port number of the source. And then destination port, it's 16 bits also, 2 byte. That is going to identify the port of the destination port packet. And then you'll have length. Length is nothing but the length of the UDP, including the header as well as data. It is a 16-bit field. Okay. And then checksum, it's a 2-byte long field or maybe 16 bits. So it's a 16-bit ones complement that you will enjoy, and then you'll have the pseudo header of the information, and of course the data as well, that is being padded to the 0 octets. So unlike the TCP, checksum calculation is not actually important in the UDP. So here there is no flow control or maybe error control in the UDP, but of course it depends on the internet protocol and internet control message protocol for the error reporting. Okay. Also UDP will be providing port numbers that you can differentiate between the user requests. So here you will have source port, destination port, length, and then checksum along with the data. So this is nothing but the UDP header, and this is the final process. And finally, the applications of UDP, you can use it for the simple request response communication as well. So when the size of the data is actually less, you can use for this one. Of course, not much concern with regards to flow control or maybe error control. And of course, for multicasting applications, you can use them, and you can use it in the routing information protocol. Okay. So for real-time applications, for the tolerance, for better efficiency, you can use the user datagram protocol. Okay, so you can use it as a transport layer protocol as well. So network time protocol, domain name service, bootp, dynamic host configuration protocol, network news protocol, you can use them. And you can use for the TFTP, RTSP, and resource initiation protocol as well. So through the application layer, you can use it for the trace route as well as the record route as well. And you can also use it as a timestamp event. So this is how you can use it for the network services in the network layer, and you can attach to the header and you can send to the user as well. So here it is going to take the datagram from the network layer and attach it is header, and it is going to send to the user. So the process is actually very fast. Okay. So UDP, user datagram protocol, is a null protocol when you try to remove the checksum. Okay. So of course it is going to reduce the requirement for the computer resources as well, and you can use the broadcast or maybe multicast as well for transfer of resources. And since you are going to transmit the real-time packets, of course you can use it in several multimedia applications.